Alright, so those of you in video land, I trust I've salvaged the previous examples I just did. We're on number 14 now. A higher gear. Something happened with my software. On behalf of ViewSonic software, I apologize. And I'm waiting on my class now to give me some advice
Well,
of simplifying this puppy. Phone's away, Delocha. You're the man.
well, I see that there's negative exponents, so can we just flip them?
Let's do some flipping.
And we can cancel out that y to the 0 power to a 1.
Man, Diaz is on this. Thank you, Delocha. So in other words, she's going to apply two rules right at the same time. She's going to apply the 0 exponent rule, because there's a y to the 0, and the negative exponent rule right at the same time. Let's just get right to it. I love it. Love it, love it. Watch. They write the fraction bar. 13 stays put. 13 doesn't move. 13 is not raised to any negative power, so that stays right where it's at. Doesn't move. The only things that move are the things that have negative exponents. So the x to the negative fifth goes to the bottom with a positive 5. Y to the 0 power becomes 1, but I don't even need to write 1. It's going to be just times 1, so there's no need. I trust you follow my thinking there. So this is gone. I took care of that. How about 5 to the negative third power? Where does that go?
To the top.
To the top. I'm going to put times 5 to the third.
And z to the negative 10th goes up to.
Goes up to the top also. And we're done.
Really? Really?
Now, what we could do, since it looks kind of funky, you've got 13 times 5 to the third power, z to the 10th. At this point, we kind of do want to clean this up because it looks too weird. Like right here, 13 times 5 to the third. Let me go ahead and clean that up and just actually do the 5 to the third power. In other words, let me get my calculator out. Let's put this calculator to work. 5 times 5 times 5. See, 5 to the third power really means 5 times 5 times 5, which I want to say is 25, if I'm not mistaken, huh?
No, because 5 times 5.
125, brother. Yeah. 125 times 13. So it's 1625. So my final answer then. Now on your work, I'm not going to mark it wrong if you just leave it this way, but it does look kind of funky. It's kind of bad manners to leave an expression where you have two numbers that are multiplied and you don't actually do it. Let's simplify that. So it comes out to 1,625
Z to the 10th.
z to the 10th over x to the 5th. No biggie. No biggie at all. Last but not least, here we go. Last but definitely not least. Where's that one I wanted to do? Yes.
Oh.
This is going to prepare you. This is going to prepare you for the that problem of the week. For those of you who are brave of heart and want to try it. This will be our last one for today. Go ahead and copy that down. First thing I ask myself is,
What rule am I going to apply to it?
before you say that, you have to say something else.
Self.
Self. What rule am I going to apply? Here we go. Diaz, do you have any ideas? You can go different routes. There's different routes you can take. They all lead to the same path if you apply the rules correctly.
Oh.
Any ideas?
I would rewrite it. I would use the rule number 2, the negative exponent.
Let's do it. So that negative exponent rule first. Love it. Here we go. So let me rewrite this first parenthesis here inside. Whatever has negative exponents, I'm going to move.
So 3.
3 stays put, huh?
3.
3 stays put because that's the first power.
And then m to the second power
Well, m.
is to the negative 5th, and the bottom one is to the negative 2.
Okay, so that means we're dividing with the same base, huh?
Oh.
So we can subtract the exponents. That's, in other words, that's rule number 4. The quotient of powers. Remember, if you're dividing with the same base, you could subtract the exponents. But, so here's what I'm going to do. To make it a little more cleaner, let me offer a suggestion. Let's take care of this exponent on the outside here, this one and this one first. In other words, let's do the 6th rule, I want to say. The 6th and 7th rule. That says, look, if you have stuff in parentheses, if you're multiplying that stuff in parentheses, just take every item to that power outside. Or if you're dividing in parentheses, just take every item to that power outside. Let's do that first. The 6th and 7th rule. The 6th has to do with multiplying, the 7th has to do with dividing. They're kind of both at the same time right now. I'm going to take everything in this parenthesis here to the 2nd power first. Here we go. 3 is to the 2nd power. Look at this now. M to the negative 5 to the 2nd. That's power of a power. That's the 3rd rule, I want to say. Actually, no, 5th rule. If you take a power to a power, you multiply those exponents. Stop me if I'm going too fast. So negative 5 times 2, I want to say is negative 10 if my coffee is kicked in. Trust my coffee has been kicking in now. And look at n squared to the 2nd power. Again, power to power. That's the 5th rule. That's n to the 4th. Nice. Fraction bar. Let's deal with the denominator now.
So 4 to the 2nd power.
Nice. 4 to the 2nd. Very nice. M to the...
I'm not good at multiplying negatives.
So we'll practice that. You're rushing on negative and positive. That's fine. We'll address that. Power to power, that's 5th rule again. If we multiply those puppies, what's negative 2 times positive 2? Anybody remember?
Would that be negative 4?
Thank you. If the signs are different, it's always negative if you're multiplying. M to the negative 4th.
And you don't have to write, or...
N to the what?
Oh, n to the 2nd power.
What's 2 times 0?
0. Okay.
We didn't have to write it though, you're right.
Right.
I think that's what you wanted to say, huh?
Yeah.
So technically you're right. Let's take care of now, look at, let's take care of the 2nd parenthesis now.
So m to the 2nd power.
Nice. N to the...
N to the 8th power.
Nice. Power to power, N to the 8th.
Wouldn't that be... No.
You're good, you're good. 9 to the...
2nd power.
2nd.
N to the 2nd.
N to the 2nd. Rocking and rolling. Question so far? So all we've done is use the 6th and 7th rule. The 6th and 7th rule.
Well, the 5th, the 6th, and the 7th.
To be more correct. Very. I like the exactitude and the precision.
And I haven't had my coffee, mister. Think about it.
Yeah. That's impressive. That's impressive. Watch this now. I got a nasty fraction times another nasty fraction. I'm gonna go back to my junior high days if my coffee is kicked in. Fraction times a fraction is called numerator times numerator, denominator times denominator. In other words, this stuff times that stuff, and then denominator times denominator. Watch. 3 to the 2nd power I'm just going to put as 9, because that's 3 times 3. Okay, that's 9. Watch this now. M to the negative 10 times m to the 2nd. I'm multiplying, look at the multiplication, and I have the same base. What does rule number 3 say I could do? I think there's 3.
It says that you could add the exponents.
Exactly.
All the powers.
I can add the exponents.
So that would be
M to the what?
n to the negative 8 power.
Right? Negative 10 plus 2? Negative 8 power. Let me keep it color coded here. M to the negative 8 power. Again, same base, And I'm multiplying n to the 4th times n to the 8th is going to be n to the what, Diaz?
12 power.
Thank you. We're adding the exponents. I'll stop there. Questions?
None.
All right, cool. Let's do the denominator now. So we're just multiplying a nasty fraction times another nasty fraction. Let's do the denominator times denominator. Here we go. 4 to the second is really 16. Times 9 to the second is 9 times 9. That's 81. So I'll put those right now. I'll deal with that later. Just take care of the numbers.
M to the.
M to the negative 4th, huh? I can't multiply with anything, so I'm just going to put that there. I like to cross it out when I'm done. N to the 0 times n to the second, same base.
Would you still be adding those together? So it's n to the second.
N to the second power, huh? So far, so good. Rocking and rolling. Let's clean it up still. We still got stuff to clean up though. The first thing I'm going to do is I'm going to multiply the 16 times 81 on my calculator. See what it spits out. So let's see, 16 times 81. I get 1296. So let me rewrite this now. 9m to the negative 8th n to the 12th divided by 1296 m to the negative 4th n to the second. Any other ideas? We can still clean this up. There's still some more rules to apply.
Well, n and n, they have the same base.
Perfectly
So
said.
We could, what is it? If we're dividing, we can subtract their
Exactly.
power.
So look what Diaz is saying. M and M, I'm dividing, there's a division bar with the same base. Rule number 4, I want to say. Let's see, was it 4? Yeah. If you're dividing with the same base, subtract the exponents. Look at the examples here. Nice. So, the train breaks, huh? Yeah, so like, yeah.
Yeah, so like, yeah.
Exactly. Academic language. Huh? M to the negative 8th divided by m to the negative 4th is going to be really, watch this now, you got to be careful. M to the negative 8 minus negative 4. Ouch. I'm subtracting the exponents, the negative 8 minus a negative 4. Careful. Let me do the n's also now. Look at n to the 12th, n to the second. That's going to be n to the 12 minus 2 power. Rocking and rolling. Let's keep going.
So now,
Right.
n is a 9, right?
So let's see. Negative 8 minus a negative 4. Let's deal right here.
That's
Oh yeah.
negative
Let's do the 9 first. I got you. And I'll put the 1296 here.
That's m to the negative 12.
Close. What's negative 8 minus a negative 4? Help.
Oh, wait. It's negative 4.
Nice.
Because
Because what you have to, this is a plus plus here. So then you have a double negative, so it's really negative 8 plus 4, which is negative 4, huh?
Mm-hmm.
So m to the negative 4th
And to the
and to the
10th.
10th power. Whew!
Damn,
We're still not done. We're still not done.
We get rid of that negative by bringing it down.
You know what I'm gonna do right now? Well, yeah, let's bring it down now. Exactly. Good, Diaz. This is a negative exponent. It's got to move. So that's gonna go down, huh? So I got 9 over 1296. M to the positive 4th, that goes to the bottom right here, and then n to the 10th at the top, and we're done. Sorta. Let's see if I can simplify the numbers, the fractions. The 9 and the 1296, if it's a fraction, let's simplify it. Let me see if 9 goes into 1296 on my calculator. So 1296 divided by 9. Nice.
Yeah.
So watch this. 9 divided by 9 is 1. N to the 10th. 9 into 1296 is 144. 144. M to the 4th. But since we're professionals, I don't have to put that 1 right there. Because there's always a 1 in front of a variable. Whew.
Yeah.
Done.
Mister,
Yes.
can you zoom out so I can copy everything?
Sure, absolutely. Let me zoom out. This is nice.
That was a long problem,
Look at that.
but we did it.
Exactly.
Okay. So.
There's a lot of teachers at Pomona Unified that couldn't do what we just did right now. Pat yourself on the back if you want. Thank you, Delocha. Nice and loud. That's good.
Kind of sore right now. I can't do that.
So,